Hello, welcome back to another lesson in calculus. We are really studying limits hard right now, just plowing through these things, trying to understand them. I hope you're having some success. Today, we're going to take limits in a different direction. We have been thus far studying limits at a value. We've been taking limit as x approaches some value c. Today, we're going to stretch that to where we're going to find limits at infinity, which is also an extremely important part of calculus. So let's dive right in. Is use the graph of f of x to estimate the limit value. Okay, the limit as x approaches -1. All right, that is what we've been doing, so we should be able to do this. As x approaches -1, from the left we approach 6, from the right we approach 6, so that value is 6. The limit as x approaches negative infinity. So we have a negative infinity and a positive infinity that we can do. So we can do one in each direction. Well, we're kind of just estimating from the graph, but this dotted line here is supposed to show that there's a horizontal asymptote that this graph is getting closer and closer and closer to as we move this way. So as f of x has x go to negative infinity, the value of f of x is going to 2. Now the limit as x approaches positive infinity is this right hand behavior. You can see that that graph is just going to continue, or at least our best guess is from the picture, to go down. So down to y values that are negative infinity. All right, so in a nutshell, that's kind of the idea, y'all. That's what we're going to be doing. Let's take a look at another couple of examples. All right, in this one, this is a graph of x to the -1. You might be more familiar with seeing it written like this, 1 over x. So remember, x to the -1 power is equal to 1 over x. I want you to start making that connection immediately, because x to the -1 power is going to be a more common way that we're going to write it in this class, just because it makes the algebra a little easier. It's just a very common way to see it, but we know that it's 1 over x, so it has that 1 over x shape. What appears to be the limit as x goes to infinity? Well, I hope you can see that it appears to be going towards 0. And what appears to be the limit as x approaches negative infinity? So as x goes towards negative infinity, I hope you can see that that is also going towards 0, right? In general, what can we say for a limit at infinity of 1 over x to the n? So what I want you to realize is that I'm doing x to the -1 here, but this could be x to the -2nd, x to the -3rd, really any positive n value, okay? Whenever, well, I guess that's confusing. Any negative exponent, because I'm calling it negative n, right? Or 1 over any positive n. That limit, as x goes to infinity, of 1 over x to any power, any positive power, has got to be 0. Likewise, as x is approaching negative infinity. All right, let's think about that another way. Why would that limit be 0? Well, think about it. If I take the number 1 and I divide it by an infinitely big number, a number that is going to infinity, right? X to the n is going upwards to infinity. So if I take a number 1 and I divide it by a number that's getting infinitely big, I'm going to be dividing that into smaller and smaller pieces. Yes, it won't ever actually be exactly 0, but it's going towards 0. Every time that denominator of x gets bigger, those pieces get smaller and smaller and smaller. And making it like 1 over x squared, that's just going to make it go to 0 that much faster. So I hope we can agree on that. because we're going to use that. We're going to take that on faith, okay? We're just going to believe it. I tried to explain it in a rational way to you, but if you're not sure, just believe it that limit goes to 0. All right, so that being said, we're going to apply it, okay? All right. Example 7.2, given f of x equals 3x to the 7th minus 8x to the 3rd plus 9. Let's evaluate each. All right, so first thing we're going to do is we're going to plug in. And if you know the shape of this graph and you know your end behavior stuff from pre-calculus and algebra 2, this could make this problem a little quicker, or at least be able to check your work, but it's not necessary. So I'm going to plug in infinity, because that's what we do with limits, right? We try direct substitution first. Okay. Well, what is negative infinity to the negative 7th power? And again, I'm being lazy. I'm saying negative infinity, but I really mean negative some number approaching infinity. Well, it's going to still be negative because it's a negative to an odd power. So I'm going to call this negative. Now, what is infinity to the 7th power? Well, it's infinity, agreed? And if I multiply that by 3, still infinity. Okay. Over here, I've got negative infinity cubed. The negative is going to stay negative because of the cubed, but that negative is going to make it positive. Infinity cubed is infinity. Multiplying that by 18 is still infinity. All right, and then I have plus 9. So this is what we call an indeterminate form. Okay? Had this been a plus 18, I would have had negative infinity minus infinity plus 9, which is, you know, if you're at negative infinity, then you subtract another infinity, and then you add a tiny little 9. I think we could agree that's still negative infinity. But this is indeterminate. We've already seen one indeterminate form. Do you remember it? A number going to 0 over a number going to 0. That's indeterminate. Now we've got a new one. Infinity minus infinity. What does that equal? Well, it doesn't equal 0, because this infinity might be going to infinity faster than that other infinity. We have no information about it. So that's me plugging in. I'm actually going to erase that. So what we found is direct substitution did not work. It will sometimes, so please don't skip that step, because when it does work, it saves you a lot of time. So we're going to have to do something different. Now, this is a technique that we only do with limits at infinity. There are a variety of different ways of doing this. This is how I do it. I'm going to factor out x to the biggest exponent there is, complete opposite of what you would do in algebra. In algebra, you would look at this and say, oh, there is no common factor. I can't factor out at all. No, we're going to factor out the x to the largest power there is, x to the 7th. And watch what I have left. I get a 3, no more x, minus 18 x to the negative 4. When you factor out, you divide, right? So I'm dividing x cubed by x to the 7th. And when you have the same base with different with powers, you subtract them. 3 minus 7 is a negative 4. Another way to think about that is that I need a number of x's here that when if I were to distribute, to check my work and distribute this x to the 7th, would give me x to the 3rd, and 7 minus 4 is indeed 3. All right, next, plus. Now this was 9x to the 0 power, because x to the 0 is 1. But now it's x to the negative 7, because I pulled out 7 x's. All right, ooh, you know what I did? I forgot to write the word limit, and I didn't plug in. So, good news. I can do that. You probably can't on your paper, and 1,000 pardons. Limit as x goes to negative infinity. All right. Now I'm going to plug in. So this becomes negative infinity to the 7th power times 3 minus, what does anything to a negative power give you when you plug in either positive or negative infinity? Well, it gives you 0, right? This is going to be 1 over x to the 4th, and 1 over a negative infinity is 0. That is positive 0, negative 0, doesn't matter here. All right, what is that going to be? That's going to be 0 as well. So negative infinity to the 7th, bring that over here, is going to be a negative infinity because I have a negative to an odd number. Then times 3. And that's still just negative infinity. It is important to consider that what this value became, because if it was like a negative 3, then we'd end up doing the positive infinity. But that's all it can do. It's not going to change it from being infinity. Notice nothing indeterminate there. All right, let's try the next one. Let's plug in infinity. 3 times infinity to the 7th. Infinity to the 7th is just infinity. Minus 18 times infinity to the 3rd. Plus 9. So that's infinity minus infinity. I don't know what that is, right? That is indeterminate. So we have to fix it. But you know what? I'm just going to skip right to this moment here. I've already factored all that out. I'm just going to trust I did it right. Don't even need to redo it. And I'm going to plug in. So this becomes infinity to the 7th, which is infinity, times 3 minus 0 plus 0. Because anything to a negative exponent with a value going to either positive or negative infinity, that is automatically going to be 0. And so that's infinity times a positive 3. That's infinity. All right. Looks like you have a practice problem. So, pause the video. Please take your time. Do the best you can. And then we'll go over it. All right, let's see how you did. Ooh, you know what? First thing I'm going to do is I'm going to rewrite this, okay, with fractional exponents. So I'm going to write that x to the 1/3. You're going to learn that in calculus class, fractional exponents are where it is at. We like fractional exponents, we like negative exponents. All right, let's evaluate. I have negative infinity to the 1/3 power plus 5 times negative infinity minus negative infinity squared. The cube root of negative infinity is negative infinity. Keep in mind we can take the cube root of a negative number. I just can't take an even root. That's minus 5. That's a 5 times a negative infinity. That's minus infinity. Negative infinity squared is positive infinity, but that's with a minus on the outside. So this is negative infinity, minus infinity, minus infinity. Is that indeterminate, or do we know what that does? We know what that does. It just goes really negative infinity, right? All right, so that one we did not have an indeterminate form. We were able to evaluate the answer without doing anything kind of special. Let's try the next one. Maybe we'll be as lucky. I get infinity to the 1/3 power plus 5 times infinity, so far so good, minus infinity squared. All right, that's not going to work because we have infinity plus infinity minus infinity. You can't say, oh, well, 2 infinity minus 1 infinity is 1. No, doesn't work that way. Not at all. That has nothing to do with the answer. Okay, so we got to do algebra. All right, I'm going to factor out, what do we do when we're doing limits to infinity? We do something completely bizarre that I don't know of any other time that I do it. We factor out the largest value of x. So we're going to factor out x squared. Factoring x squared from x to the 1/3. So I got to subtract 1/3 minus 2. That's a 2 over 1. So what I'm going to do is simply multiply this by 3 over 3. So I get 1/3 minus 6/3, which is a negative 5/3. Okay. Okay. Next, I have plus 5x to the first divided by x to the second is x to the negative first, and then minus 1. So let's plug in infinity now. We get infinity squared, that's infinity. That's a 0. That's a 0. That's a minus 1. So I end up with negative infinity. All right? So this function went towards negative infinity, both to the left and to the right. All right. Got another couple of practice problems for us to do here. Or example problems, I should say. All right. For each, evaluate the limit as x approaches negative infinity and positive infinity. Then state the equations of any horizontal asymptotes. All right? And we'll check by graphing. That'll be fun. All right. So here we got a rational function, and what we're going to do is the exact same thing we just did before. We're going to plug in. We're going to see if we have an indeterminate form. If we do, we're going to factor out the largest power I can of x on top and on bottom. So let's see what happens if I want to evaluate the limit as x approaches negative infinity. I would get 8 minus infinity squared minus negative infinity squared times 4, which is kind of pointless. Then I have 9 times negative infinity squared plus 5 times a negative infinity. And I end up with 8. Let's see here, that's a negative infinity squared because a positive infinity, but times a negative 4, so it's 8 minus infinity over negative infinity squared is a positive infinity, so it's 9 times infinity is infinity, and then minus infinity. All right, well, this is just a giant mess. I got negative infinity on top, and then I've got an indeterminate on bottom. Not going to work. And I'm going to tell you, even if I think if we plug in positive infinity, I think we end up with something like negative infinity over infinity plus infinity. This is never going to be okay. So that's another indeterminate form. Infinity over infinity, we have no idea what that is. And so if you've got x's on top and bottom of a rational equation and you're trying to take a limit at infinity, it's going to be an indeterminate form every time. So you can actually skip that step of plugging in infinity if there's x's on top and bottom. But I wanted to show you why and what happens. All right, so we're going to have to factor some things out. We're going to have to do some algebra. I'm going to factor out the x squared. Remember, it's weird, but we're doing limits at infinity, so we pull out the biggest value of x that exists. That gives me 8x to the negative 2 minus 4, and the x squared is gone. On the bottom, the biggest exponent was also x to the second, and I'm left with 9 plus 5x to the negative 1. All right, now, before I plug in, though, I have some reducing that I can do. So I reduce that, and now this is what I have left. All right, so let's plug in. I get 0 minus 4. So 0 minus 4. I like to put the zeros, just make sure I've done it. 0 minus 4 over 9 plus 0. That equals negative 4 over 9. So the limit as x approaches negative infinity is negative 4 over 9. Let's do the limit as x approaches positive infinity. Guess what? We've already done most all the work, so we get to skip right to this step right here. I'll just rewrite it for documentation purposes. All right, here I go, plugging in infinity. That's going to give me 0 minus 4 over 9 plus 0 is a negative 4 over 9. So you can see that the limit is the same towards negative infinity as a positive infinity. And so now we can say horizontal asymptotes. But I didn't really give you a formal definition of one, but here it is. A horizontal asymptote is y equals a real number when you take a limit at infinity. So if I take a limit as x approaches in positive infinity and I get a number, then I have a horizontal asymptote. Horizontal asymptotes are simply the answer to the limit at infinity. So this begs the question, how many horizontal asymptotes can I have? Two. I can have one as I go to positive infinity and a different one as I go to negative infinity. But that's it. I can only have two of them. Because they are limits as x approaches an infinity. This time it happened to be the same one, so I have one. All right, let's do another one. The dreaded square root rational function thing. But the calculus is fun. All right, let's skip the plugging in here and just say, hey, this is going to be indeterminate. It's going to be at best infinity over infinity. And let's just jump straight to finding the limit as x approaches negative infinity. All right, so what I'm going to do is I'm going to factor out the largest exponent of x that exists on top. But because I got that pesky square root, I'm kind of stuck with it there, and I have to keep it inside it. So I do that, okay? Don't worry, I'm going to take care of it in just a second. But that becomes 6x to the negative 2, then plus 4, right? Please don't think you can just take the square root of 6 and then the square root of 4x squared. You cannot distribute a square root over addition. You can only distribute a square root over multiplication. Like, for example, not the square root of 9 plus 4 does not equal 3 plus 2. I mean, come on, that's the square root of 13, not 5, right? But the square root of 9 times 4, you can do that, right? That does equal 3 times 2, because that's 36. Square root of 36 is 6. So that's the key. That's what we're trying to do. We're trying to make it multiplication. Once it's multiplication, then I can pull them out. All right, let's see here. We're on the bottom, though, right? I have to factor out an x. And I get 1x to the negative 1 plus 2. Yeah, I guess I don't need the 1 anymore, because I got... Okay. All right, now, like I said, we can take the square root. I can't do of the inside of this, but I can take the square root of each one of these portions. So let's do that. The limit as x approaches negative infinity, the square root of x squared is the absolute value of x. And then the square root of the rest. I'm telling you, y'all, if you want to get math wrong, all you need to do is forget that the square root of x squared is the absolute value of x. It is not x. Think about it, right? If I put in a negative number for x here, like negative 2, I would get 4, and the square root of 4 is positive 2. Okay, it's the absolute value of x. All right, well, we have learned that the absolute value of x is really a piecewise defined function, where it's negative x if x is less than 0, and it's positive x if x is greater than or equal to 0. And I can actually put it equal to here or there, it doesn't matter. So, if I'm taking a limit as x approaches negative infinity, that means x is going more and more and more negative. So in reality, absolute value of x in this situation is a negative x. So this is really the limit as x approaches negative infinity of negative x times the square root of 6x to the negative 2 plus 4 over x times x to the negative 1 plus 2. So these do reduce, but they reduce to a negative 1. And now I'm going to plug in. I get negative 1 times the square root. That's a negative 2, remember? So that's a 0 plus 4 over 0 plus 2. Now the square root of 4 is 2. So this is a negative 2 over 2. This is a negative 1. So the answer to this limit is negative 1. Now let's go back to this situation as we evaluate the limit as x goes to positive infinity. As x is going to positive infinity, the x's are clearly positive, so we should be using the regular x branch. So it's just regular x times the square root of 6x to the negative 2 plus 4 over x times x to the negative 1 plus 2. That means these reduce to a positive 1 And I'm going to go ahead and plug in infinity now because I just got a 1. So that's 6 times infinity to a negative power. We know that's 0 plus 4 over 0 plus 2. So that's 4. The square root of 4 is 2. So this is 2 over 2, which is a positive 1. The question asks us to describe what kind of horizontal asymptotes we have. We have horizontal asymptote of y equals 1 and y equals negative 1. All right, let's check the graph. So I'm going to pull up a Desmos graph here. Let's take a look at it. All right, so we are looking at f of x is equal to the square root of 6 plus 4x squared divided by 1 plus 2x. Okay, can you see what's happening? We have two distinctly different horizontal asymptotes. This one is indeed approaching 1. Approaching it looks like from the below, interestingly enough. It was above for a little while, and then it dipped down below, and then it's coming back. So this one here, same thing. It's going to dip down. Actually, it's not. But it is approaching negative 1 as we go closer and closer there. Also coming from below. So that's the story. All right, now let's graph the other one. We had 8 minus 4x squared divided by 9x squared plus 5x. And we said we had one horizontal asymptote of a negative 4 over 9. So we should see this approaching negative 0.44444444. And likewise over here. Yep, getting closer, right? There it is. So, yep, looks like we did it right. All right, it is time for you to do 2 last practice problems. Please do them to the best of your ability. Pause the video, and then we will go over them together. Okay, welcome back. All right, we got x on top and bottom. There's no chance that we can just plug in. It's always going to be some kind of infinity over infinity, so we need to do some work. I need to factor out the highest exponent since I'm doing a limit at infinity. You get x cubed. That becomes 1 minus x to the negative 2 plus 5x to the negative 3 over... All right, we're factoring out an x to the 4 on bottom here, so I'll pull out x to the 4th, and then I have 2x to the negative 4 minus 5. Okay, we're going to reduce these, right? But notice they don't cancel all of the x's. I still have one more x on bottom this time. I hope you caught that. So now let's plug in infinity, negative infinity. I'll get 1 minus 0. I don't care about the sign, right? This negative squared, and it doesn't matter. It's a 0. So whatever, minus 0 plus 0 doesn't matter. Here's another 0, right? Over x, which is a negative infinity, right? Times, that's 0 minus 5. All right, so what does this become? 1 over... That's negative infinity times negative 5. That's actually a positive infinity. It turns out I don't care because going back to that same old situation, I have 1 divided by infinity. If I take 1 and divide it by a number that's getting bigger and bigger and bigger, I get a number closer and closer and closer to 0. All right, let's try the limit as x approaches positive infinity. I'm going to just take it right from there and plug in. I have 1 minus 0 plus 0 over infinity times 0 minus 5. That is definitely 1 over infinity. says negative infinity this time. I don't care. It's still 0. It's just coming from a different direction, but it's going to 0. So what's the horizontal asymptote? Y equals 0. Let's check it right quick on a graph before we do the next one, just to make sure that we're doing this right. X cubed minus x plus 5 over 2 minus 5x to the 4th. Okay, I think you can clearly see that this is definitely going towards 0. So we have the right horizontal asymptote. Okay, let's see how you did. We'll start with the limit as x approaches negative infinity. And I can factor out the largest exponents. I have x squared, which gives me 1 plus x to the negative 2 over, factor out x to the first, x times 4x to the negative 1 minus 1. Okay, so the square root of x squared, remember we can take square roots of products. We can split it around multiplication. So I can do this side and then I can do this part. So it'll be the limit as x goes to negative infinity. The square root of x squared is the absolute value of x. Then the square root of 1 plus x squared, I have to just leave it like that. I can't distribute it across addition. On the bottom, we still got that x, and I'll just rewrite everything again. All right, now when x is negative, the absolute value of x is a negative x. And if this is negative x divided by positive x, it will reduce to a negative 1. So this is negative 1 times 1 plus x to the negative 2 over 4x to the negative 1 minus 1. That's what I'm taking the limit of. All right, let's plug in. I get negative 1 times the square root of 1 plus 0 over 0 minus 1. 1 plus 0 is 1. The square root of 1 is 1. 1 times negative 1 is negative 1. 0 minus 1 is negative 1. Positive 1. All right, let's do the next one. The limit as x goes to positive infinity. I'm going to jump down to this moment right here. All right, so we know that the absolute value of x is the same as x for positive x values. So this reduces now to a positive 1. So this is just the square root of 1 plus x to the negative 2 over 4x to the negative 1 minus 1. And we're taking a limit as x goes to infinity. So remember, everything that's got a negative exponent, when I plug in infinity, becomes a 0. So this is 1 plus 0 over 0 minus 1. The square root of 1 is 1. 0 minus 1 is negative 1. The answer is negative 1. So, again, with that square root, it gives us two different horizontal asymptotes. Let me just write that up here. We have a horizontal asymptote at y equals 1 and at y equals negative 1. Let's check that on our graph before we call it quits. So this was the square root of x squared plus 1 over 4 minus x. All right, so down here you can see that we are approaching this value of 1 here, right? Slowly, but it's approaching it. As we go to the left, we're going to get closer and closer to that value of 1. Over here, though, we're getting closer and closer to the value of negative 1. So we have our two limits. Okay, well, that's it for today. We'll look at limits at infinity a little bit more tomorrow. I know they're challenging, but just stick with it, follow the process, and look for patterns. Look for patterns so that you can predict what the answer will be before you even do the algebra. All right, so until next time, take care.